Brains are crucial for how we handle life in general, from our heartbeats to our feeling to our walking around. And language is no exception. Without a working brain, there be no talking, no listening, and no meaning. So, our brains run our language operating system, but there are specific parts responsible for our conversations. It is not the whole brain job. The cerebrum is the largest part of the human brain. It enables sensory perception and controls voluntary motor actions. The cerebellum lies inferior to the cerebrum at the back of the head. It is mostly involved in coordination of movements and fine-tuning of motor activities. Cerebrum has four major lobes. The frontal lobe is associated mainly with voluntary motor functions, motivations, emotion, and social judgment. Parietal lobe is mainly concerned with sensory functions of the somatosensory category such as touch, movement, temperature, and pain. The temporal lobe is associated with hearing, learning, visual memory, and language. The occipital lobe is located at the rear of the cerebrum. This is the visual processing center of the brain. Lastly, the brainstem is located at the base of the brain and is continuous to the spinal cord. It houses all nerve connections between different parts of the central nervous system.
The cerebrum consists of two cerebral hemispheres. The left hemisphere controls the right half of the body. The right hemisphere controls the left half of the body. The two parts of the brain that co-share the language community is the Broca's area. It is in the left frontal lobe of the brain. That part takes care of the deeper workings of language, how to put good grammatical sentences together and how to decode the logical meanings of the phrases and sentences we are hearing. It also helps with moving our body the right way to talk, which is the body language. The other part is called Wernicke's area, and it is in the left temporal lobe of your brain just above your ear. Wernicke's area is the hyperactive librarian of language, in charge of the vast storage of your mental dictionary. It takes care of quickly working out what words that you have just here and quickly matching up those sounds or visuals to your mental meanings. It then ships them off the Broca's area for processing into sentences. Wernicke's area is also where you want to start to get to talk. It's the region where you work out which sounds are the right ones for the words you want to say before you ship them off to Broca's area for arranging and pronouncing. Wernicke's area works on comprehension and meaning, whereas Broca's area holds the linguistic structure and the logic of language.
If the delicate web of language network in your brain becomes disrupted by stroke, illness, or trauma, you could find yourself truly at a loss for words. This disorder, called aphasia, can impair all aspects of communication. Aphasia is just any type of disorder that involves language. There are several types of aphasia grouped into two categories, which is fluent aphasia and non-fluent aphasia. People with fluent aphasia may have normal vocal inflection but use words that lack meaning. They have difficulty comprehending the speech of others and frequently unable to recognize their own speech errors. People with non-fluent, on the other hand, may have good comprehension but will experience long hesitation between words and make grammatical errors. Having aphasia can make it hard to name simple, everyday objects. Even reading and writing can be difficult. There are other types of aphasia. We have agraphia, which is the inability to write, anomia, difficulty to name things, and other specific difficulty in reading, spelling, grammar, and pronunciation. When Broca's is damaged, people tend to have trouble producing speech. Their words become halting. This is called non-fluent aphasia or Broca's aphasia. When Wernicke's area is damaged, you get Wernicke's aphasia, which is quite a different pattern of behavior than you get with Broca's aphasia. They have no trouble producing words, but the words that do come up don't make any sense, and they also have trouble understanding what other people say. When both Broca's aphasia and Wernicke's aphasia are present, then you have something called global aphasia because it globally affects language instead of only affecting a subsection of it.
In 1861 in Paris, France, Paul Pierre Broca published a report in the Bulletin de la Société of a case of aphasia associated with a lesion in the left frontal lobe that at the time he called aphemia. The patient, Mr. Libogny, was a 51-year-old man with a previous history of aphasia and right hemiplegia who subsequently went into a coma and died. Broca performed an autopsy and found destructive lesions in the second and third frontal convolutions of the left cerebral hemisphere, the inferior margins of the sylvian fissure, the insula, and the adjacent part of the striatum, confirming his ideas about the location of language. The specific frontal lobe region was later defined as Broca's area. The patient, Mr. Libogny, became known as Tan because of the expressive aphasia he suffered from, as a result of which he could only keep repeating Tan Tan. This was described in the case report written by Broca in 1861 and published by Dronkers in 2007. He could no longer produce but a single syllable, which he usually repeated twice in succession. Regardless of the question we asked him, he always responded Tan Tan, combined with very expressive gestures.
Genetic basis of language (SLI) is another reason that causes language disorder other than aphasia. SLI is one rare language disorder, seems to be inborn rather than the result of damage to a previously normal brain. Children are born with a natural instinct to acquire language, which is LAD. However, a tiny minority of babies are born with an apparent defect in this LAD. Certain families appear to have a hereditary language acquisition disorder, labeled specific language impairment or SLI. Children born with this disorder usually have normal intelligence, perhaps even high intelligence, but as children they are never able to acquire language naturally and effortlessly. They are born with their window of opportunity already closed to natural language acquisition. These children grew up without succeeding in acquiring any consistent grammatical pattern. Thus, they never command any language well, even their native language. SLI sufferers are incapable of perfecting their skills through being taught, just as some people are incapable of being taught how to draw well. So in conclusion, we have specific regions in our brain dedicated to processing and understanding language, that we have multiple methods of measuring the activity so we can learn how we process our language.